Bismillah. Welcome back. In this class, we shall discuss what is a resolution of an image and how does it affect the quality of the image if the resolution is increased or if the resolution is decreased. So, the basic simple definition of a resolution is the number of pixels per unit distance. Unit distance, or you can have as a square area. So the number of pixels per unit distance. More the resolution, the finer the quality of the image will be, and at the same time the size of the file will be larger. Lesser the resolution, the quality of the image will be poor and the size of the file will be smaller. Let us take a simple example. Now see that this image has 256 by 256 resolution. That means in this distance, in the horizontal distance, there are 256 pixels, and in the vertical distance there are 256 pixels. Therefore the pixels are very near to each other. Therefore we get a finer quality of the picture. The same picture, if I have, instead of 256, if I have 128 pixels, and by 128 the image of the quality of the image will be little bit decreased, and at the same time the size of the image will also be decreased. And instead of 256, if we make the number of pixels 64 by 64 that is in horizontally 64 pixels, vertically 64 pixels, this is how the image. And see, when the resolution is reduced to 32 by 32, the image becomes even dull, and here the image is 16 by 16 number of pixels, and here you can count itself. See that this is 1, this is 2, 3, 4, 5, 6, 7, 8. 8 pixels are in the horizontal direction and 8 pixels are in the vertical direction. Therefore, in the same unit distance, if the number of pixels are 8, it is very hard to identify the image. If we improve to 16, then also the image is very poor. And if we make 32 by 32, the image has jerks, that is, it has shades. And likewise, if it is the resolution is even increased 65 by 64, we can find the image. And when it is the higher the resolution, the quality of the image is finer. Poorer the resolution, the quality of the image is very difficult to find out. So for this, let us write how we can achieve this in MATLAB. So I have started in MATLAB. Now I will take this one. Im is equal to im read. I will take the file newborn.tif. Right. Now is this newborn.tif. Im read newborn. The image is newborn.tif only. I did not put the quotation mark, therefore newborn.tif. Now let us see that image. So im show the image im. Right. So now you can see that this is a 256 by 256 image. Now if I reduce the image, say for instance, if I take im1 is equal to, there is a command called im resize the image. I want to reduce it to say for example 1/4 of that one, that is point. Yes, we shall reduce by 1/8 of its size. And now if I see the image im show im1, then you can see that this image, the image size of the image has become 1/8 of that one. Okay, now but as per the definition of the resolution, we should have the unit distance. Therefore what we have to do is, even we reduce it to 1/8, what shall we do is, we shall again resize this to the original size. Therefore again I apply the im resize, the command. You reduce it to half, and since I want a unit distance, therefore I make it the actual size. Okay, now let us see the size, and now we can see that this is the image which is where the pixel is reduced, And the earlier picture, we saw that the earlier picture is this one. I take figure I am show and I will give the title. This is the original image, and now you can compare these two images, figure 1 and figure 2. So see that the unit distance, the units are same, that is the size is same. This one is the higher resolution. You can see here 256 by 256, the higher resolution. If I reduce the resolution, see that the quality of the image is very much reduced. This we shall do by seeing all the other resolutions. Therefore what I will do is I will take a new MATLAB file. Let us close all the figures if it is open. Let us clear all the memory locations. Let us clear the command window. I will take the image is equal to imread. Now the image is equal to newborn.tiff. Alright. And now I will show the image. Therefore, otherwise we shall show the images at the end. Now I will take A is equal to resize this image. The image I will reduce it to half the size, but we want the resolution to compare with the equal size. Therefore again I say resize. Since I reduced half, I make it the double. Alright. Now the same way, now we shall have this is this one 2 3 4 5. Alright, now this one I reduce the image by 1 by 4, and to make unit distance I again expand it by 4. I reduce the size by 1 by 8, and to get the same size I again make it 8. This one is again reduced by 16 and expanded by 16. Likewise I can make this one equal to reduce by 32 and expand by 32, so that the sizes we can compare are equal. Right here actually 1 2 3 4 5 6 images are there. Therefore I will use a function called as subplot. I want 3 rows and 2 columns, and this is the first figure. Now here I will show this one is equal to show which figure. I will show the image and here I will give the title. This resolution is 256 by 256, that is the original image. Alright, here there should be a quotation. Alright, the same way I want to show the other figures also. So 1 2 C D E F. Alright, so this I will call it as the variable B, this we shall call it as C, and this one is D, this is the image E. Therefore now we shall show 1 2, we shall 3, this is the 4th image, 5th image, 6th image, and 7th image. Now there are 3 into 2, therefore only 6 images are there. Therefore this I will cut it. Here I will show only this one. I will show this one is equal to image A, this is image B, and here we shall have the image C, which is reduced, and this one is image D, and likewise the image E. Right, so this is extra. So this will be my first image, and the second image, third image, fourth image, and fifth image. Alright, so this one is basically A is we have reduced by 2, therefore 256 by half is nothing but 128 by 128. Alright, and this image will be, since half of this one, therefore this is 64 into 64, and this image will be 64. This image will be, since we reduce C is equal to half of that, this one, the first one is 256, the half of that one is 128, this is 32 cross 32, and this will be equal to even half of that, so this is 16 by 16, 16 by 16, and this image will be half of that one, so this will be equal to 8 cross 8 image. Alright, now I have to compare with the original image, therefore I will take this as figure, and I am show the actual image is and here I give the title is equal to 256 cross 256, because I find from the workspace that this resolution is equal to 256. Alright, this we shall save this one, and now let us run this, and if I increase this one, if I make it a little bit bigger, so I think one mistake I did, 1 2 3 4 5, one more image, A B C D E. Alright, 1 2 4 8 16 32. Even we can take one more image which is reduced by 64, which is reduced by 64 and expand by 64 and expand by 64, and that image we shall take here, Control C and this Control V, and this one is my sixth image, and this one is my image F. Therefore this should also be my image, not E, it should be F, and half of this one, therefore it should have in the same distance, it should have a 4x4 resolution. Right, now let us save this one and let us run this, and now I have two figures. I think this one should also have been figure, and this one I can make it as a figure, and let us save it, and now let us run this. Now I have two images. This one is my 256 by 256, this is my resolution. Now when the image is reduced half of the resolution, then this one is 128 by 128. See that the image quality is getting reduced. When the image is 64 by 64, even the quality is getting further reduced. 32 by 32, the quality is even further reduced. 16 by 16, hardly it is difficult to find out what the image is. 8 by 8, even still the image quality is very poor. 4 by 4, we cannot identify the image itself. See that this is 1 pixel, this one is 1 pixel, this one is 1 pixel, and this is 4. 1 2 3 4. Likewise 1 2 3 4, only 4 different shades we get. So this is a 4 by 4. This way we can understand that the resolution plays a major role in image processing. Higher the resolution, finer the image and larger the size. Poorer the resolution, poorer the quality and lesser the image size. So this is a simple example which illustrates the concept of resolution. So basically the resolution is the number of samples or number of pixels per unit distance. To make the unit distance equal, we have, even though we reduce by 2, and to make the size equal, I increase the size by the size what I reduced. Alright, on this please subscribe my channel, and please do write comments. Your comments alone will help me to improve me. Thank you so much.